And we're back. Welcome back to the Observability and Security track. I am here with Phil Wilkins, who's going to share how to make logs work for you with Fluent D. Have fun, Phil.
Lovely, thanks very much. Hello, everybody, and I hope you're having a good conference so far. And let's get started. So let's do that. There we go. This is me. Um, all my content you'll see today is available online already. All you need to do is to make note of one of these links, and you'll be able to find your way to it. So no worrying about trying to grab things or jot things down. Um, Just a quick introduction for myself. So I am recently joining Oracle um, as a cloud developer evangelist, having worked previously at system integrators and niche software houses and end user organizations. I have written or co-written several books and peer-reviewed many more. So, just a few of those contributions are down there in the little picture. The one that you might be most interested in is, if we can move on, here we go, is this one, recently published through Manning, and it's all about the use of Fluent D and how it fits in legacy landscapes or non-cloud native landscapes, as well as fitting into cloud native and Kubernetes and lots more. And a few bits from the book will appear in this session. This is my get out of jail, just in case I say something that Oracle would rather I didn't say publicly. Not that I'm going to be particularly talking about Oracle um, in this session. Um, so first step really is to think about what it means by monitoring and logging and analytics. Um, there's been quite a development over the last few years about the thinking and ideas um, behind this. And one of the key things here, or one of the key ideas, is the so-called three pillars of observability, which we can define as metrics, which is your numerical data type, such as your CPU usage, your memory usage, statistics like that, transaction volumes, perhaps. Your logs, which are largely going to be textual or semi-structured in nature, things like what's the application doing, error events, SNMP traps on your networking, and details like that. And then within the application, we want to be able to trace what's going on, particularly when we're doing functional testing and when we're trying to do problem diagnosis. We want to know what's going on and understand where the time is being used up and details like that. Now we can take those three pillars and overlay those onto the different parts of an end-to-end solution. And what's interesting, and the reason I did this was, depending on your role and your interest, you are going to have different perspectives on what monitoring is and how much logs help you. So if you look at the infrastructure and the host monitoring, you're going to be heavily numerical, as I say, sampling your CPU usage, your disk storage, memory consumption, process percentage of your allocated compute, and things like that. If you're thinking about your DevOps person who's probably looking after a Kubernetes or a VM farm of some sort, um, then you'll see perhaps a little bit less in terms of pure numerical data, and you will start to see some logs. No real trace information relevant at this stage, but your logs are going to do things like CPUs spinning up, virtual machines starting, stopping, things like that. And then we get into application monitoring, and this is, I have to admit, my background, so I will tend to talk about application perspectives in this session, but everything that applies at this tier holds true on every tier. Um, so there's nothing here that's unique to applications. But from a three-pillar observability, we've got some metrics. We're going to be wanting to know about the throughput of our application, the latency of our queries, things like that. Definitely logs. That's normally your first go-to, and of course, then particularly if you're getting into microservices and things like that, you're going to want to look at tracing. And then moving up the stack, right at the top, you've got your business application perspectives, which is now rather more about individual transactions, but the transactions within a business process. So how many orders have you passed through in the last minute and things like that. And then we've got two cross-cutting perspectives, capacity and capacity management. And on the other side, we've got security, which comes together under the banner of SIEM, which brings all your security considerations together. So um, we've seen over the years, particularly in the last few years, complexity of our landscape um, grow. When we started out, we may well have just been dealing with um, utilization in the low end where we're dealing with maybe one or two processes, maybe a little bit of inter-process communication, but not much. And then into the 80s, 90s, we saw Tomcat and servlets. So we saw some web traffic and load balancing of services and things like that. SOA was around, and that tended to be single-threaded process management across multiple processes. And then we've come into the world of Node.js and Kafka, um, where we're seeing now hyper-threading and thread management, where we're using threads across many contexts or sessions to get even more efficiency through. And then, of course, we've got to think about fully distributed through containerization and microservice technologies. And it's going to get even more complex. As we enter the world of multi-cloud, serverless, which makes things very transient, um, and considerations such as that. So it's just going to get more and more complex, and the monitoring in your logs and the activities that give you a picture of what is actually going on is just getting spread further and further. So we've got a real challenge, and the traditional way of just signing into a server and looking at the logs of your application is just dead. It's not going to work in these complex landscapes. So we need to change things. We've had some tools around for a while that have been dealing with this, and Fluent has been around. It's about um, 10 years old now, but really it came into its own about 4 to 6 years ago when we started to see the hyperscalers, um, such as Amazon and Google and Oracle for that matter, although a late joiner to the game, adopting Fluent to start helping internally, but also providing services to us as users of the cloud, um, deal with that problem of trying to bring logs together. So let me show you quickly how it plugs. So it's a highly pluggable framework with inputs and outputs, obviously. And in the middle, we can format and manipulate log events. We can filter log events out, so we can take the mundane logs that just say, everything is fine, and strip those out and only share the log events that tell us perhaps something might not be quite right, or the log events that have got data in that we actually want to measure. We can parse them in a number of different ways, and that includes dealing with date time information, multi-line log events, and all those sort of things. We need to optimize this as well, so we've got the ability to work with buffer and caching. We can persist the logs in just about any location you can imagine, from S3 compliant buckets through to NoSQL databases to Elasticsearch to Mongo to flat files, and integrate and store through third-party cloud services or other applications. And if you come up against a scenario where actually there isn't a pre-built plugin, then it's very easy to build your own custom plugin. So it's a real tool to solve just about all the issues you could come up with in dealing with log events. So ingesting them, doing something, routing them somewhere, processing and filtering out the key events. Now, FluentD is not going to solve every aspect of your monitoring needs. And this is a view of its capabilities. So if you think about the life cycle of a log event, whether that's pure data or that's purely unstructured content, you're going to need to capture it somewhere. You need to ideally apply some structure to it, because structure gives you meaning. It allows you to create the rules and direct these things. And then we need to aggregate and analyze. And that normally means bringing them, consolidating them, particularly in a highly distributed world, bringing them together in a single, more manageable location, and then performing some analysis on it. And you can see on the left-hand side that the first 2.5 steps are very much FluentD's strong point. But the visualization and doing alerting and notifications to actually make events actionable, get people to deal with events that are a challenge, um, we are going to lean on other tools. FluentD is not trying to be the jack of all; it is a master of a few. Um, but what it does do is allow you to integrate many, many other products and tools into the equation to do the tail end. As I say, you can do analysis through logs being pushed into Elasticsearch or Splunk, which is a popular licensed product. You can visualize data off these kinds of environments very easily. And of course, we can drive notifications out uh, or actions, and that could be to Jira, it could be to Slack, it could be PagerDuty, or many, many others. So if you're aware of this part of the landscape, and most people have sort of a vague awareness at least these days, may have come across the Elk Stack, which is Elasticsearch that I mentioned, Logstash, and the Kibana visualization layer, which is, there we go. And then we've got the FluentD version of that, which is becoming known as EFK. Elasticsearch is still there. Kibana is still providing the visualization, but rather than using Logstash and Beats, which is its lightweight one, you've got FluentD and FluentBit. Now, why use EFK over Elk? Well, FluentD is far more pluggable than Logstash and Beats, as is the FluentBit. The footprint is smaller, so it can be deployed in lots more locations, giving you a lot more freedom. The FluentBit is a classic solution to monitoring IoT, Internet of Things. So you can put it into smaller locations. Okay, some real world challenges. Well, I've mentioned highly distributed, whether that's containerization and having many containers, and we can put Fluent Bit or Fluent D into containers if we want. So IoT, um, to wanting to monitor end-to-end solutions. Monitoring one application of an enterprise is not going to give you the full state of where you are. You're going to want to monitor your infrastructure. You're going to want to monitor potentially dozens of different applications. For example, your ERP might be there to do your accounting, but you need to make sure that the data is getting into it. Maybe you're doing some sort of supply chain manufacturing, so you've got the warehousing systems and the pick and the manufacturing services all needing to um, capture log events so that you can see the root cause of your problem. So if your ERP starts receiving stops receiving transactions like sales, is that because the ERP's got a fault? Is that because your supply chain has got a fault? Is that because your manufacturing is not pumping out the things on demand, for example? So some real challenges. And therefore, the question becomes, how can we apply and deploy Fluent D? So here's a distributed view. And in this picture, you can see I've got multiple applications. Some are native on a server, some are in VMs. And what I'm doing here is um, bringing the log events together with a node running Fluent D. You can see here um, or over here, and it's filtering out key events, sending those to an ops service such as um, PagerDuty, and also pumping the events into a persistence platform to do the bigger, heavier analytics. Now, the reason for doing both is um, we ideally want to move into a world where we can be preventative. Now, if we can identify log events that are indicative of a potential issue, we can actually get those events out before we run our periodic, say, every 10 minutes analysis on our logs. That 10 minutes could be the difference between prevention and remediation and recovery. Yeah. And that could be really interesting. Um, so, we can move ourselves into a world of being more proactive. And actually, life is easier if you're preventing problems than trying to remediate after the event. If you run out of disk storage, then your transactions are going to start falling out all over the place. That's customers being affected um, ultimately, and delayed time and more work in trying to restore and check your data integrity and roll back transactions and make sure that you haven't lost anything. And if your SLAs are being impinged because it's taking a long time to recover, you got the consequences of all of that. But that could easily be um, in a deployment that's running across multiple Kubernetes or containerization clusters. And rather than servers, we're talking about pods and worker nodes, and we can be looking at both the pods and the worker nodes with our Fluent D setup. And here you can see there's a slight variation on it. I mentioned the Fluent D and Fluent Bit. Very quickly, there's the difference. Fluent Bit's just a very small footprint version of Fluent D, um, and it doesn't have all the transformation and aggregation manipulation. It's a log collector and folder. So let me give you a little bit of a demo. Um, it's a bit Mickey Mouse, but it gives you a sense of the idea that um, of what's possible. So what I've got here is on my machine, I've got two log simulators. that I'm going to start running now. And they're generating log events, simulating an application, generating log events. And there's my oh, first generator picking up here. And the tool I've got is very chatty in the left-hand side. On the right-hand side, the second log generator, I've switched off the chattiness just to show this is a utility that I wrote to go with the book to help demonstrate use cases. By rather than trying to run applications and create logs, I can replay logs or play synthetic logs in. Then what I've got is two nodes. Here is my um, IDE, Visual Studio in this case, but you can use it in just about anything. And I've got two configuration files here, one on the left, one on the right. One config file serves one node, and a second config file serves a separate node. So that what we can do is do one of those distributed styles. Let me just bring my slide up back and I'll show you the layout. So here is node one. So I've got two log files being monitored. They could be one or multiple applications, and they're aggregating them to get the information together. So that I got a copy of everything going in one place. If I need to go back and look at every little minute log event that ever occurred, I'm writing the logs locally as well. But I'm taking out those events which I could deploy that node on multiple servers, and I'm going to push it to another server, another node. Now, because FluentD's got a really tiny footprint, I'm able to set this up and run it all on my local machine without breaking sweat. Now, what you've got here is the logs being collected, filtered, and then key logs are going to my Slack desktop. So I've integrated my FluentD to my Slack account. And it's also going to be bumping out some log events to the console. So you can see I'm filtering them and getting rid of the noise and getting down to the nitty-gritty. But one of the other things you've got to do when you're doing, particularly when pushing notifications, is you don't want to create mailstorms. That's things pinging away and flattening your monitoring capability with messages to the point where you can't stop and look at what's going on. So you effectively want to send the first or a couple of critical events and then suppressing them for a time. Now, in this demo, I am suppressing for just 1 minute. So here is where is it? There's my suppression. And I'm saying, okay, for 1 minute after two events, um, suppress for 60 seconds. So let's quickly look at my use case. I'm sourcing tailing files just as we might do ourselves. I'm putting it into a pipeline and I'm extracting some meaning out of it. Um, I'm then sending it to two locations. So I'm copying it and sending it to a file, which I mentioned locally, and I'm buffering them up a little bit and then pushing it out to another server, which happens to be on the same host, which is this one here. It receives it, and therefore I'm now looking for a pattern in the message part of the construct, which is looking for the word on computer. So that means I can have computer and upper and lowercase. It's pushing it out to console, looking for more than one occurrence, and then doing suppression. And then those that don't get suppressed will go to my Slack. Now, if I bring my Slack desktop over, let me just do one thing. So I'm sure you don't want to see my background conversations. So if I bring my Slack over, here we go. Here's my desktop, and you can see every minute or so, it's sending me two events that are valid and then going quiet for a minute. Yeah. And so 11:15, 11:16. So if I scroll all the way down, 11:20. So literally it's pinging away. If I get that to, there you go. Right. And they're the messages. So I could just say, okay, this is a significant event. Let's do something. I could route this to a particular channel or a user on Slack very easily by just creating some rules. If I come back to my UI, there are my simulators. So you can see one of my simulators is now in, and the other one's well the way through. And here's my Node 1 console output. And you can see it's been pushing out to the console events. And you can see it's just refreshed as more events come through from that first simulator. I look at Node 2, it's very, very quiet because it's only pushing one or two through to the console. And you can see because I've got it chatty, you can see it's loaded up my config, and that's the core of a little Fluent D. Now I'm looking for just the word computer. You could look for a word error. You can make very complex rules through the use of regular expressions and things like that. Right, let's get back. So that was my demo. Very, very noddy. But the other thing you can do is you could extend this very easily and pump this into analytics, and you can integrate Prometheus and Kibana. Uh, if you want to work with a specialist security tool, you could integrate that in and send logs to that. And you don't have to do it via files, you can do it directly, just in the same way as the web traffic flowing across there was. They can be across clouds. So you could be running one bit in Google, another bit in Azure, and perhaps another bit in Oracle if you wanted. That was my config just in case. And that's me flown through a little presentation, give you a little flavor of Fluent D. So we have a little bit of time available to deal with any questions, if anybody has any they'd like to ask.
There haven't been chat so far. Do you know any alternatives to Fluent D, which are also open source? Because I know a lot of paid solutions, but none of them that I've
Yes,
looked at.
so probably the most well-known one is Logstash,
Yeah.
which is the Elk stack, and that's open source as part of the Elastic suite of products. There are a couple of other lesser known open source ones around, but Fluent D is by far the dominant one, and part of that comes from the fact that the Fluent D is under CNCF, which is the Cloud Native Foundation. So it means that it becomes part of the family of products, if you like, that are both open source and well integrated into Cloud Native. Yes, and someone's mentioned Fluent Bit. Fluent Bit is like the baby brother to Fluent D with a limited capability. And Fluent Bit is exceptionally good for very, very small footprint solutions, but Fluent D is not very big. You can run that little demo that I've just done on a tiny little Arduino or a little device like that, just as easily as your desktop. So,
Nice.
so question, when is Logstash actually better than Fluent D? I mean, typical use cases. Interesting. The question. The answer to that is I wouldn't say it's better. It's just different. Um, the reason I might consider Logstash over Fluentd is if I am trying to minimize the number of different sources of software. So if I'm using other parts of the Elastic stack, then maybe I'd consider Logstash over Fluentd. Um, Related to that might be a skills related issue within your organization because the configuration files are different between Logstash and Fluentd. So it becomes a little bit of a preference thing, but Fluentd doesn't take huge amounts to get on top of. If you're familiar with sort of XML based notation, um, then you're well on your way.
Do you use Fluentd also in production in
Y-
any of the applications you use?
yes,
Hmm.
yes. So Oracle um, eats its own or dog food or drinks its own champagne, depending on your preferred expression.
Yeah,
And a lot of the monitoring that goes on in its cloud behind the scenes is actually got parts of Fluentd in it.
nice.
Okay, so what solution is best for visualizing Fluentd data? Elastic and Kibana or something else? Um, Again, this is dependent to your preferences. Elastic search, if you know how to get it, and Kibana using that, they're perfectly fine. But if you're doing particular use cases, particularly security-based monitoring, um, you might want to consider Splunk because it's got the rules and intelligence to actually process and extract meaning out of that data. Yes, we can integrate with Graylog. One of the inputs that Fluentd's got as a standard adapter is the Graylog format. Any others? I will say there's some good questions coming forward. If you think of something at a later date, then please feel free to contact me. You can see I'm on Twitter and LinkedIn and various social media platforms. Um, so feel free to always ping me at a later date, and I'll try and help answer those questions. And of course, dare I say it, little plug, a lot of this is in the book as well. And back to your question about production, one of the appendices in the book is actually a composite of a couple of real world scenarios where had to address the monitoring needs um, using these technologies.
Nice. I love hearing that when you eat your own dog food like that, I think it makes the end product better at the end of the day.
Yeah, if you live by what you're selling, then you at least understand the problems and the challenges with the tools,
Yeah.
um, and work to make it better. And the community out there is phenomenal. Um, it is a very active community and incredibly informative.
Yeah, yeah, I can imagine. Is there, so I'm assuming you've used it for a bit. Is there anything that's missing that you feel like, or what are they working on with regards to the future? You know that?
The harder parts, I would say, is dealing with secrets at
Hmm.
the moment. Um, and that is being improved, is my understanding. Um, and that's Fluentd. That's not specific to Oracle.
Yeah,
Um, of course, you could write your own adapter very easily to pull the secrets out of a resource yourself. Um, the so that's probably the hardest thing at the moment. Because obviously, if you're dealing with Elasticsearch, you're probably going to be wanting credentials used to pass the data in.
yeah,
Um, but you don't want that in clear text in your config. So that's probably the trickiest bit. And the other area I would say is quite challenging is if you want to get in and you've got a manually deployed Kubernetes stack where you've deployed everything yourself rather than using an opinionated platform like OpenShift or one of the cloud provider Kubernetes, because there's some real complexity in there. Kubernetes logging is a binary. When it shuts down containers, it trashes all but the last little bit of your logs
Mm.
straight away to salvage resources. So all of a sudden, you could lose logs um, out of your output if you're not routing it through a logging framework.
Yeah, that sucks because then the fact that it shuts down also kind of removes your logs in that way.
Yeah,
Yeah.
yeah. Um, it's and of course Kubernetes as well. Even with simpler deployments like Minikube, the way it's set up is they're trying to keep you out of messing around in the lower layers. So you've got to understand the security setup to be able to navigate and find what's going on at the very lowest layers and pick up those log files to try and get at that layer.
Yeah.
Okay.
Let's see. Let's do one final round. If you have any questions left, put them in the chat. And otherwise, we'll end it a bit earlier than usual.
Yeah, I blazed through a little bit quick, I think, because I forgot to set my timer.
No worries. I like the demo bit. That also the fact that you kind of set up a local Slack project just to show how the notifications would work.
Yeah, it's was remarkably simple to set up, and I think it's something I would recommend anybody consider, um, as long as you've got that suppression in place uh, to so you don't swamp yourself with messages.
Yeah.
Uh, just getting those nudges rather than having to watch what's going on or having a warboard always on above you and watching what's being spat out in uh, those dashboards.
Yeah.
But if it's important, it's nudging.
How do you balance between kind of noise, right? Messages that you don't necessarily have to act upon, and
That
actually crucial messages.
that's probably the hardest bit, and it's incremental. So I never put Slack into place to start with.
Mm.
I start by just building out a second log file. So I write to another log file or um, Elasticsearch or somewhere convenient to keep a filtered version of my log events. Um, and that's what I'm looking for is to see what's going into that,
Yeah.
and then I'm dialing it back. Um, Depending on the maturity of your organization, if you've got a very mature ops organization, they'll know what log events are critical.
Yeah.
So regardless of the tool that they're using, they'll be able to say that log event is the most important. So it becomes then an exercise in taking that understanding and in, developing the filters so it filters out just to those key events.
Very
And
interesting.
And of course, one of the bottom lines with this, your login is only as good as your log events being generated by your code.
Yeah.
So if your code's not being very helpful, then your monitoring and your log processing is not going to be very helpful.
Yeah, that's where it starts, right?
Yeah,
If it's absent or if it spams too much, um, it starts with the code.
yeah. Spam's not so much of an issue because you can, as I say, filter it down.
Yeah.
Either using the log framework or just using something like Fluent D to cut it down.
Yeah.
But, um, you know, if the messages are ambiguous, if you have one message for all exceptions, it's not really going to help you. Uh, Go, actually, that exception is purely a casting error, and my application will handle that.
Yeah.
Um, Through to throwing and catching the same exception through your stack. Um, at that again, it's bad coding practice, um, to keep catching and throwing, but you know, that means that potentially you're going to get that same exception stack being generated in your logs,
Yeah.
and that's just undue noise. And then the question becomes, where did it originate from in the first occasion?
Yeah. Yeah, that makes sense. How much of a log message would you kind of generalize and make more specific, I guess, because you do want to pinpoint where an error would occur.
So the practice that I've always recommended, for serious production quality solutions is anything that's important, give it a log code.
Hmm.
Yeah, and any error should have its own error code. And then all you need to do is set up a little spreadsheet or a table in Confluence or another wiki. And every time you add a new code, you just put a little entry in and say it comes from here. And if you want to be really helpful, you can express why that error code might have occurred. Um, and over time, if you're practicing ITIL, you'd develop from that into documentation that says when this issue occurs, this is the path to remediation.
Yeah.
Um, and that remediation might be completely manual, um, but ultimately, in the ideal world, that's becomes automated.
Yeah.
Yeah, and that automation might be, okay, we're just going to let Kubernetes trash that node. Um, or it could be, hey, we can see database queries slowing down. We need to perhaps go and do some TLC in the database because it needs compacting, or maybe the indexing needs rebalancing, things like that.
Yeah. It makes sense. Do you think it'll get outdated? Because if you, for example, if you specify your log codes, your error codes, put them in Confluence, your code might change, right? But Confluence might not be updated as such. Kind of the
That's
fear I
al-
always have.
yeah, that's always a risk.
Yeah.
Um, if you're really nervous about that sort of thing, you can write parsers on your code to build that index up.
Yeah.
Um, but that's quite a bit of effort, and most people, particularly because it means that if you've got a separate ops team, um, if there's the ops are a separate team, then they're going to want to build up their own documentation associated with your error codes.
Yeah.
How they've been most successful at remediating how a problem. They might want to go into a lot more detail than you as a developer because you know how to remediate your code, um, and you'll know things which we, we all too easily forget to write down. And when some poor ops person at 2 o'clock in the morning that's um, starved to sleep is trying to solve a problem, having a very detailed step-by-step sequence of things to do, um, they're going to find that a lot more helpful than when you as a developer jumping in to sort out a logging error
Yeah.
against your own bit of code.
That makes sense. Cool. Let's round it off, Phil, here.
Lovely.
I love the demo. I love the little tidbits you went into detail on. Also, actually showing the notifications in Slack. Very nice. So Phil Wilkins, everyone, check him out in the speakers notes. All the links to his socials will be there. If you have any remaining questions, let us know, and we'll see you on the next one. Um,
Lovely. Thank you. Hope everybody has a good day.
for sure. We now have an hour break. So enjoy your lunch, and we'll see you in an hour again.